In this video, we will represent relations in multiple ways and identify its domain and range. So first, a little vocabulary. What a relation is. A relation is a set of ordered pairs. So we have this relation here with the points -1, 4, 0, 6, 5, -2. So these three sets of coordinates are representing a relation. So we can represent relations in many different ways using a table, a graph on the coordinate plane, ordered pairs, mappings, or equations. And we're going to see examples of these in a minute. The domain of a relation is the set of all possible x values. So in each of our points here, the set of all possible x values just come from the x values of each of those ordered pairs. So our domain is x equals -1, 0, or 5. The range is going to be the set of all possible y values in a relation. So here our y values are 4, 6, and -2. And the way we notate what our range is y is equal to the set that includes -2, 4, and 6. Notice every time I'm notating a set of things, I'm using those curly brackets. So I have the domain and range here that include these values. It's a set of values, so I'm including them in the curly brackets. The relation itself is a set of points, so I've included that in those curly brackets. All right, here are our representations. We have ordered pairs, mapping, table, and graph. So we're going to start out with our set of ordered pairs, our relation. So what is our domain and range? We could go through each one of those ordered pairs and pick out the domain values, which will be the x values, or the range values, which will be the y values. But the mapping is actually a way to organize our ordered pairs to show us the domain and range. The mapping, we have circles for x and y values, so we can pick out from those points that our domain should be 5, 3, 2, 0, and -1. Now, of course, we would list them in order from least to greatest, so we would actually list them from -1, 0, 2, 3, and 5 when listing our domain. Our range, notice it only has 3 values. Why do we think that is? Well, notice in those points that -5 and -2 actually repeat. So we only need to list those once in our range. So the domain is actually shown here in the x bubble in our map, and the range is actually shown in the y value of our map. But our mapping's not quite complete. The mapping can actually show you which points are connected to what. We know that the 5 is connected to -2. We have the ordered pair of 5, -2. 3, -5. 2, -5. Notice how -5 has 2 arrows going to it. 0, -2. Notice again we see the repetition there. And -1, -3. So a complete mapping will actually show you the domain and range and how those points are related in ordered pairs. The table is just an x and y t-chart. So we're listing our points according to our ordered pairs. So 5 is with -2, 3 is with -5, we have an x coordinate of 2, y coordinate of -5, 0, -2, -1, -3. Notice how we didn't condense our list of y values here, because we are actually trying to show the correspondence between each x and each y. And then of course our graph, we will show our points on the coordinate plane. So 5, -2, 3, -5, +2, -5, 0, -2, -1, -3. So these 4 ways here are really representing the same relation. We just have the ordered pairs here, the mapping here, the table, and the graph. They really are representing the same relation, just in different forms. So the next problem is on your own. I've given you the table of values. I would like you to write out the ordered pairs, write the mapping, and the graph. The graph can be a rough sketch, but make it at least readable where you could tell where those points would be if it was on graph paper.